Imagine waking up to your last day on Earth and not knowing it. 66 million years ago, that's exactly what happened. Not to you, not to me, but to creatures who had ruled this planet for 165 million years. The dinosaurs had survived ice ages, volcanic eruptions, continental drift. They'd seen continents split apart and oceans form. They were the most successful animals in Earth's history, until one random Tuesday morning when a piece of rock from space decided their time was up. This isn't a story about extinction. This is a story about violence on a scale so massive, so complete, that it rewrote the rules of life itself, and we know exactly how it happened. Because the Earth recorded everything, every second, every death, every fire. The rocks don't lie. Let me take you there, to the Yucatan Peninsula, Mexico, to a shallow ocean, warm and teeming with life, to the exact spot where the world ended. But first, let's rewind 10 seconds. Just 10 seconds before impact, life is normal. A pteranodon glides over the water, scanning for fish. Below the surface, massive mosasaurs hunt in packs. On the shoreline, a herd of Alamosaurus drinks from a freshwater stream. The air smells like salt and vegetation. The sun is high, it's peaceful. Then someone looks up. High above, something appears, not slowly, not gradually. One moment, the sky is empty. The next moment, there's a streak of light, brighter than anything that should exist. It's not falling, it's not descending. It's screaming toward Earth at 45,000 miles per hour. The asteroid is 6 miles wide. Mount Everest is 5.5 miles tall. You do the math. 5 seconds before impact, the atmosphere starts to scream. The air in front of the asteroid can't move away fast enough, so it compresses into a superheated shock wave. The temperature reaches 60,000 degrees. The sky doesn't just light up, it ignites. Any creature within 1,000 miles looking in that direction goes permanently blind from the flash, but they won't have time to worry about it. 3 seconds. The ocean below the incoming asteroid starts to boil, not from heat, from the shock wave pushing through the air. The water surface ripples, then churns, then explodes upward in the steam. Fish float to the surface, dead from the pressure change. Birds fall from the sky, their lungs collapsed. 1 second. Every animal on the Yucatan Peninsula stops moving. Predator and prey alike frozen in place. They can feel it now, a vibration in the air, a pressure in their bones. Something is catastrophically wrong. Their instincts are screaming danger, but their brains can't comprehend what's about to happen. Nothing in their evolutionary history prepared them for this. 0 impact. The asteroid doesn't splash into the ocean. It doesn't crater. It punches through the water like it's not even there, through the sea floor, through limestone rock that took millions of years to form, through solid bedrock, 12 miles deep into the Earth's crust. All in 0.8 seconds. The energy release is incomprehensible. Take the most powerful nuclear weapon humans ever built, the Tsar Bomba. Now multiply it by 6 billion. That's the impact energy, released in a space the size of a city, instantly. The bedrock at ground zero doesn't melt, doesn't crack, doesn't shatter. It ceases to be rock. It becomes gas. The temperature exceeds the surface of the sun. First second after impact, the shockwave explodes outward at 4 miles per second. That's 14,400 miles per hour through solid rock. The earthquake that follows isn't on any scale humans have ever created. It's magnitude 11.3. The entire North American plate jumps, literally lifts up and slams back down, Mountains in Mexico crumble like sand castles. The ground rises and falls in 30-foot waves. Solid bedrock moves like ocean water during a hurricane. Every dinosaur within 600 miles dies in the first second, not from the heat, from the ground itself. They're thrown into the air, slammed into rocks, crushed under falling trees. The Tyrannosaurus Rex in Texas never knew what hit him. One moment he's standing, the next moment the ground punches him 50 feet into the air. 3 seconds. The impact crater is now 15 miles wide and is still growing. But something strange happens. The Earth's crust, compressed beyond its limit, rebounds, like dropping a pebble in water and watching the splash bounce back up. Except this isn't water. This is continental bedrock. A mountain of liquefied rock shoots up from the crater, 15 miles high, higher than the stratosphere. This molten peak glows white-hot against the darkening sky, and what goes up must come down. 10 seconds. The shockwave has traveled 40 miles. The Gulf of Mexico has been pushed away from the impact site, exposing the sea floor. A wall of water 300 feet tall builds up at the edges, preparing to rush back in. But this isn't the worst tsunami. The worst one is still forming, and it's heading for the Atlantic Ocean. 30 seconds. Now we need to talk about the ejecta. When you punch a hole 12 miles deep into the Earth's crust, all that rock has to go somewhere. Trillions of tons of vaporized and liquefied rock shoot out of the crater at escape velocity. Some of it literally leaves Earth's gravity and flies into space, but most of it goes up and comes back down as molten glass, as superheated rock, as doom itself, spreading across the entire planet. 1 minute after impact, the seismic waves have reached Montana, 2,000 miles away. A Tyrannosaurus Rex feels the ground shake. She looks south and sees something that shouldn't be possible. The horizon is glowing, bright orange, fading to red, climbing higher into the sky. She doesn't understand what she's seeing. She just knows, with every instinct in her body, that she needs to run. But there's nowhere to run to. The thermal radiation hits her first. The air temperature rises from 85 degrees to 200 degrees in minutes. She seeks shade, but shade doesn't help. The air itself is heating up. 3 minutes. The tsunamis start hitting coastlines. These aren't normal waves. The first one to hit the Gulf Coast is 400 feet tall, traveling at 600 miles per hour. It doesn't crash or break. It simply erases everything in its path for 100 miles inland. Entire forests, mountains, thousands of species gone in minutes. The water is filled with debris, trees, boulders, dinosaur bodies tossed like toys. 5 minutes. The impact has created a hole in the atmosphere itself. The superheated air at ground zero has shot straight up into space, creating a temporary vacuum. Now air from hundreds of miles away rushes in to fill it. Winds of 1,000 miles per hour scour the landscape. These aren't hurricanes. This is the planet screaming. 10 minutes. The ejecta reaches the stratosphere and begins its global distribution. This is the moment of no return. Trillions of tons of vaporized rock, sulfur compounds from the sea floor, and superheated dust begin spreading worldwide. In orbit, this debris glows red hot. From space, Earth looks like it's been shot, because it has been. 15 minutes. Dinosaurs in Asia see the sky changing. It's mid-afternoon there. The sky should be blue. Instead, it's turning orange, then red, then a dark, bruised purple. Streaks of light begin appearing, hundreds of them, then thousands. The ejecta is beginning to re-enter the atmosphere. And when something enters the atmosphere at 25,000 miles per hour, it releases its kinetic energy as heat. The entire sky becomes a broiler oven. 30 minutes. The thermal pulse hits globally. This is the real killer. Forget the impact site, forget the tsunamis. This is what ends the dinosaur age. The air temperature worldwide rises to 800 degrees Fahrenheit, not at ground level, in the air, everywhere. Forests spontaneously ignite. The Amazon rainforest, on fire. The forests of Asia, burning. Antarctica still has forests in this era. They're burning too. Any animal caught in the open cooks alive. The lucky ones die from a smoke inhalation first. Dinosaurs crowd into caves, burrows, rivers, desperate for any shelter from the heat. Some make it, most don't. The thermal pulse lasts for hours. When it finally passes, 70% of Earth's forests are either burning or already ash. 1 hour. Half the planet is on fire. The smoke column is visible from a space if anyone were up there to see it. The temperature has dropped back to normal levels, but only because the sun is now blocked. Ash and soot and vaporized rock fill the atmosphere. They turn to twilight, then to darkness. The ejecta is still falling. Rocks the size of cars are still glowing cherry red, slam into the ground worldwide. Each impact starts new fires. The planet is eating itself. 6 hours. The first dinosaurs begin dying from smoke inhalation rather than heat. The air is toxic. Every breath burns. The smaller ones fare better. Their burrows protected them from the worst of the thermal pulse. But the big ones, the giants who ruled the land, they are suffocating. A brachiosaurus, 80 feet long and 50 tons, gasps for air that isn't there anymore. She survived for 40 years, lived through droughts, storms, injuries, but she can't survive this? 24 hours. The temperature has dropped 50 degrees. Sounds good, right? It's not. The particles in the atmosphere are blocking 90% of sunlight. What made it through yesterday was enough to cook the planet. What's making it through today isn't enough to keep the planet warm. Impact winter is beginning, and it will last for years. 1 week later, it's snowing in the tropics. But this isn't water snow. It's ash mixed with sulfuric acid from the vaporized seafloor. It falls continuously, burying everything under a gray toxic blanket. The surviving plants are dying. Without sunlight, photosynthesis stops. The herbivores have nothing to eat. The carnivores have nothing to hunt. The food chain is collapsing from bottom to top. 1 month. The die-off accelerates. Every day, more species vanish. The rule of survival is simple now. If you're bigger than a dog, you're probably doomed. Large animals need too much food, and there is no food. The Tyrannosaurus Rex that survived the initial impact, she's starving. She needs 300 pounds of meat daily. She hasn't eaten in 2 weeks. She's hunting desperately, but there's nothing left to hunt. In a few days, she'll be too weak to stand. 6 months. The sky is still dark. Temperatures are near freezing worldwide. The oceans have turned acidic from the sulfur compounds. Marine life is dying en masse. Ammonites, which survived for 300 million years, are going extinct. Mosasaurs, the apex predators of the oceans, are starving. 75% of all species on Earth are extinct or dying, but life is stubborn. In underground burrows, small mammals huddle together. They're eating seeds, dead leaves, insects, anything. Their small size is an advantage now. They don't need much food. They can wait out the winter. These survivors are our ancestors. 1 year. The dust begins to settle, literally. The heavier particles fall from the sky. Sunlight, weak and pale, finally reaches the surface again, but it's returning to a different world. The dinosaurs are gone, every single one except for a few bird lineages. The pterosaurs, extinct. The marine reptiles, gone. The giant herbivores that shook the ground when they walked, vanished. 2 years after impact, plants begin growing again, small tough species at first, ferns, mosses. They spread across the barren landscape, reclaiming the dead world, and where plants grow, animals follow. The small mammals emerge from their burrows, blinking in the sunlight. The earth belongs to them now. Our time has begun. Stand outside tonight. Look up at the stars. Beautiful, right? Peaceful? Here's what astronomers won't tell you at parties. There are over 1 million asteroids larger than 1 mile in diameter currently orbiting near Earth. We've only cataloged 40% of them, which means somewhere out there, right now, there's an asteroid with Earth's name on it. Maybe it'll arrive in 1 million years, maybe in 1,000, maybe next Tuesday. We're the first species in Earth's history with the technology to see it coming. We're also the first species with the technology to stop it. The dinosaurs never had that chance. They lived for 165 million years and ended in a day they never saw coming. We won't have that excuse. The question isn't if another asteroid will come. The question is, when it does, will we be ready? Or will we join the dinosaurs as just another fossil layer, a warning to whatever species evolves intelligence next? The universe doesn't care about fairness. It doesn't care about how long you've survived or how powerful you are. The dinosaurs learned that lesson. Let's hope we don't have to learn it the same way. Thanks for watching. Look up tonight. And remember, we have something the dinosaurs never had: a chance.